Hi everyone, so welcome to another ALEKS tutorial. This one is a little simpler than the last two. It's just making sure that we understand how to find the limiting reactant of a chemical reaction. So we have a chemical reaction between ethane and oxygen, and it's producing carbon dioxide and water. So ethane and oxygen are the reactants, and carbon dioxide and water are the products. So we want to know that if we have 4.81 grams of ethane and 29 grams of oxygen, what's the minimum amount of ethane that could be left over by the end of the reaction? So essentially, if ethane is the limiting reactant of the chemical equation, or this chemical reaction, then by definition of the limiting reactant, that it's going to be zero left over by the end, because that's what a limiting reactant is, right? It's the thing that runs out first in a chemical reaction. So, but if oxygen was the limiting reactant, then we would have leftover ethane that would be present at the end of the reaction, and that would be the minimum mass of ethane that would be left over by the chemical reaction. So I've already gone ahead and written the balanced equation and found the molar masses of everything in this problem. So if you had this problem on ALEKS, that would be the first thing that you would do. You'd write a balanced equation and find your molar masses. So now all we have to do is just find the initial amount of moles of ethane. We know that we're given 4.81 grams of ethane, so we need to convert that to moles. So start with 4.18 grams. Ethane is C2H6, and we multiply that by the ratio of 30.06624 grams of ethane per every 1 mole of ethane. Remember, that's just the molar mass flipped upside down, and we can use this to cancel grams of ethane and be left with how many moles of ethane we have. So if you do that calculation, you're left with 0.15990 or 99801 moles of ethane. So now we just find the initial amount of moles of our other reactant, which is oxygen gas. So to do that, we do the same thing. We're told in this problem that we have 29 grams of oxygen, and this is our molar mass for oxygen. So 29 grams of O2 multiplied by the inverse molar mass here, so that's 31.9988 grams of oxygen for every 1 mole of oxygen. Grams of oxygen cancel, leaving you with 29 divided by 31.9988. And if you plug that into your calculator, you get 0.9062804, or 840, sorry, moles of O2. So like we did in the previous problems, we need to find out for any one of these values, right? We need to find out how much of the other reactant is used by this amount of one reactant. So for instance, how much of oxygen are we using for every 0.15998 moles of ethane? Or if you wanted to, you could also do how many moles of ethane is consumed by this amount of oxygen. But because we started with ethane, let's just find out how much oxygen is used by that amount of ethane first. So as we did in our previous videos, we find that by using the molar ratio between our two reactants. So we know that for every 2 moles of ethane that is consumed, we consume 7 moles of oxygen gas. So on top we write what we want, which is moles of oxygen, and we know that 7 moles of oxygen are consumed for every 2 moles of ethane. As like before, the moles of ethane will cancel, and that just leaves you with 0.1599 multiplied by 7 divided by 2. So plug that into your calculator, and you end up getting 0.5599304 moles of O2. And with this, we have enough information to determine what our limiting reactant is. So for every 0.155998 moles of ethane, we consume 0.5599 moles of oxygen gas. Notice that that is quite a bit smaller than the initial moles of oxygen present at the beginning of the reaction. So that means that once all of this ethane has been used up, we've only consumed that amount of moles of O2, which is much less than the original. So that means we're going to run out of ethane. And so ethane is the limiting reactant. Okay, so we know that all the ethane's going to get used up, and we're going to have excess oxygen. So what's the question asking? It is asking, calculate the minimum mass of ethane that could be left over, theoretically, by the end of the chemical reaction. Well, we've just established that if this chemical reaction takes place, all the ethane's getting used up. So there won't be any mass of ethane left by the end. So that's just 0. And so the only thing you have to do from here to make sure that you get the answer right is check the sig figs of your problem. 4.81, that's 3 sig figs, and ethane 29 point, that's 2 sig figs. So our answer should be 2 sig figs. So this is just 0.0. That's how much ethane will be left over by the end of the reaction. If this had asked us how much oxygen was left over by the end of the reaction, then you would just take the amount of oxygen that gets consumed by the limiting reactant, which is ethane, and you would just take this value and subtract it from the initial amount of O2. So that would give you a value of what? Probably 0.35, but that's not what the question's asking. It's asking how much ethane is left over, and of course there is none, because ethane is our limiting reactant. All right, that's the end of this video. Thanks for watching.